This is Mastering Mathematics with your teacher, Karen Weston.
Hello Antigua, Barbuda, and the rest of the world. Welcome again to another in the series, Mastering Mathematics. This is a program produced by the Ministry of Education using its EPU unit, Mathematics Center, and of course, ABS Television, bringing this straight and live into your rooms. Okay, today, what are we saying? We're going to continue in that vein from yesterday. And yes, we're going to spend every minute on the mathematics, focusing on that process. So, here we are. And what are we doing? What did we do yesterday again, you said? What? Yes, right. So we were looking at our addition rule. Okay, what is the rule for addition as it relates to the topic of matrices? And why are we teaching you that? Because that is our question number 11. Part of that section deals with matrices. So we are now getting you ready for our CXC examination. And yes, the focus of this lesson in mathematics is big time examination based. Alright? My grade 6 students, I know you're getting ready for your projects. And please remember, teachers, no, it is not the topics that you got from that book that was sent out in 2006 that's dominating whatever you're supposed to do. It's not one of those topics. It's creativity and application of the mathematics information that we would have been teaching our students, that we want to see exemplified in situations in the real world, or where you'd be using it in the economy, what role you think mathematics will be playing, and how can you make your students demonstrate this in terms of a project. Do not give them fractions and tell them that this is remedial measure because it's going to help you in your paper too. That is not the purpose of the project. Purpose of the project is to show how out of school mathematics knowledge is used in the workplace. The language is important, yes, and so a written up form of it will be there, like your content, your acknowledgement, etc., etc. The format and presentation, yes, anybody will tell you about that. And remember that if you get anything from off of the website, that you must identify it, so you're referencing. So we need our bibliography. Let the children have fun in doing this project. If you said any boring topics to them, and Green Bay, I am coming down to see. Because the last time I saw Mrs. Thompson giving a lovely project, and yes, still, I can't believe how many zeros I still saw when I got the marks from Green Bay. So, I am coming down to Green Bay to see. And on the one hand, those students who felt that they had to be in school produced one of the best projects coming from the same Green Bay. Alright? So we are coming to see. It is to let those children know nothing is impossible, especially when you're putting your trust in God. And again, we need to tell you, you look and you see your prime ministers, your big politicians, everything. Where are they coming from? Okay? So yes, goodness can come out even from, all the time comes from out of the ghetto, because these are the people that are staying here and looking for methods and ways to make things work. So they have the creativity within them. Let us transfer it to formal education. So Mr. Biles, I'm on your case. Okay. Here we go. What did I give you last? Yes, okay, so you finished with the last spoonful of soup in your mouth? You're ready then? Don't worry, choke, you know. Okay. Well, you said you're eating just the last chicken bone? Look, just put on the thing and wipe your hand fast, see? And come and let's do the people's work. Good. Here we are. A is equal to -3, 4, 5, -6. B is equal to -2, -1, -9, 7. And we had to add these things. And we are not afraid, so we know right away it was -3, and it is -3, and it is plus -2. The things in the same positions are added together. And then it is 4, and it is plus -1. Okay? And then we have 5, and it is plus -9. And then we have negative 6, and it is plus 7. So, negative 3 plus negative 2. Same people, same things. How many do we have? Yes, negative 5. Then you have 4, and it is plus negative 1. And we say 2 signs here, so the big sign would be negative. So it's just the same as saying 4 minus 1. So we know right away that our answer here would be 3. Another way of saying that is we have 4 things on this side, 1 over there. Who has the most and the 4s, and by how many? Alright? So teachers, even if sometimes you need to just put in the little stones and so forth and show them, color the little things and let them see. Okay? And here, 5, and it is plus negative 9. And yes, negative 9 is bigger than the positive 5. Not value, but in terms of how many, yes. And it is negative 4. Alright? And then negative 6 plus 7. Which one has the most, and is the positive 7. And by how many, it is 1. And you don't even have to go far to look for things to get them to do, because you can use strokes too, okay? Your negative ones can be like cross, and the positive ones just straight. And they can count and say which one has the most, okay? And by how many, and you can get them. But in fifth form now, we can do these things. And this is a question too. Yes, you can use your calculators to help you. But try, when you're practicing now, that we call this the workshop, try not to use your calculators for all these little things, so that you can develop your potential for looking at numbers and just turning them over quickly in your brains. If you cheat on yourself, when you get to your multiple choice questions, bambalele, everything is going to come out, all right? So no shortcuts, okay? What you do in the dark will come to light. So please take the pain now, all right? So then this now is our answer, negative 5, 3, negative 4, 1. Can we move on then? Yes. So teachers, I want to show you, you don't have to belabor the point. Give them the concept. Show them what is involved. Have them write journals every time or anything like that at the end of the session, so that you can see, and you can check on it to see, let me see what you wrote. Or you can say, okay, over the weekend, write up what we did last week in mathematics, and then you can check and see what they're writing, and you would get a good sense, an idea of if a particular child understood what was being taught. Okay? Just do that, and you will see how you're going to enhance your mathematics passes. Then after this, now, what would happen if I change this word from addition to subtraction? Okay? And we're not even going to spend too long on that, okay? To subtraction. All right. And what did we say? And again, every time you're teaching something for the first time, don't mix up any negative numbers with it as yet. You don't want to interject any fear or apprehension for the students. They know positive numbers, give them, okay? Because what is it we want to do? For them to understand the concept when it comes to subtraction. And that should be our main focus, not several things at the same time. Okay? And then, so they can have 11, you have 12 and 13. So, instead of adding now, we are subtracting. So if we had to find A minus B, what would be the answer? And again, the things in the same positions are subtracted from each other. So it would be 5 minus 8. It would be 7 minus 11. It would be 8. It would be 8 minus 12. And it would be 10 minus 13. The sign in front of a number means that is the name of the number. Okay? So 5 minus 8, which number is bigger? The negative number. By how many? Yes, 3. So the answer here is negative 3. Here, which number is bigger? Our negative 11, right? By how many? Negative 4. Here again, 2. 8 minus 12. Which number is bigger? Our negative 12. And by how many? Negative 4. Alright? And here we have 10 minus 13. Which number is bigger? Our negative 13. We're not saying in value, alright? So it's 10 minus 13. How many? And then this then would be negative 3. Okay? And that is what we want our students to understand. When we get it now that we're giving them negative numbers, and it is still minus minus, so we're getting minus minus, we know right away a negative times. That silently in here, the operation that has to be performed with the signs is multiplication. So then when we say a negative times a negative would give us our positive, okay? And again, if you had a negative times a positive, it would be negative. All right, so the signs, work them out first, and then we can see. Right, so what do we do now? It is now time for us to let you take a break. So we're going to send you on this little break, and we will be right back to give you a little more about, one more step about our subtraction, and then we'll introduce you with the multiplication, because we want you to be expecting, can't wait for the next day to come, because you know what you're doing. And with all the things we've told you about the website, you don't have to wait on us to give you your problems. And what are we saying again? We want you to be great thinkers and constructors of information. So you're going to formulate your own question. It's not a textbook. It's what you understand when the teacher would have facilitated the teaching and shown you what the concept is. You just go and construct your own things. All right? Go and get your break. Finish off that drumstick that you're eating. Eat up that fish head. Leave some for me because I am coming. All right. In a minute, we'll be right back.
If you know the answer to a question is incorrect and you cannot find the mistake, start over on a clean piece of paper. Oftentimes when you try to correct a problem, you continually overlook the mistake. Starting over on a clean piece of paper will let you focus on the question, not on trying to find the error. Always read my problems completely before beginning any calculations. If you glance too quick at a problem, you may misunderstand what really needs to be done to solve the problem.
Join us for a new series of Mastering Mathematics, Mondays and Tuesdays, 6:30 p.m. here on ABS TV.
Hello, right. You're comfortable now. You have held your belch, so your belly is full. You're leaning back, you're perking up because we're ready. And of course you're learning, okay? So we have done our rule for addition, we know that. We've just introduced you with the subtraction because we said, yes, that's a quick one. But just for good measures, let's do another one. Give me some numbers. So yes, I heard you, -7. Was it 6? Yes. 8? Yes. -9. Okay, good. And what would your B look like? And you said you want to give them -2, -1, 5, and 10. All right. And if they're asking you to say A minus B, what would be your answer? And then we're not even doing it in our brains, we're putting it so we can eyeball them. So you have -7 minus, don't forget, minus, and the name of this number is -2. Okay, then you have 6, and it is minus, and the name of this number is -1. And then we have 8, and it's -5. And we have -9, and it's -10. Common mistake students make, because the name of this number is -2, they are completely forgetting the negative sign here. You cannot afford to do that, okay? So for every time, consciously put in your negative sign first and then write the number, because this number is called -2. All right? And then again, so we went through all this where we said 2 negatives coming like that, we're going to be getting a final sign of a positive. So you have -7 plus 2. This is going to give us 6 plus 1. And this is our 8 minus 5. And this is our -9, -10. Can't change that. -7 with a +2. Which number is bigger? It is -7 by how many? And it is -5. Okay, we're not talking in value, we're talking in terms of how many. And then we're saying 6 plus 7, 6 plus 1, and that's going to give you 7. And 8 minus 5 would leave you with 3. Now this is saying -9 and -10. How many do we have all together? And they are all of the same type, so it is -19. It's not a negative times a negative. The name of this number is -9. The name of this number is -10. So we're saying -9, and inside here the silent word and -10 is equal. So it's plus -10 is equal to how many? All right? So that is our answer for our subtraction. I will leave you to give yourself a few examples and to say, yes, you can do them. So immediately you know the rules for addition and subtraction. Let us look and see what we can tell you about multiplication. Let us look and see what we can tell you about multiplication when it comes to our matrices. Okay, when it comes to our matrices, what can we say about multiplication? So our multiplication rule, so it is now multiplication. At this time, guess what? We have to write rules, because there are 2 types of multiplication. When we take the topic of matrices, focusing on the topic of matrices, we have 2 types of multiplications. And the first one is called scalar multiplication. And the matrix, that is the multiplication that's only found when we're doing matrices, is called the matrix. Okay, matrix multiplication. That's what we're going to call it. And you know what? You will be pleased to know that scalar multiplication is something you can do, because it is so very, what Miss Weston is going to say, simple. It is so very simple. It is called a scale. So let us look at scalar multiplication. And the question we're asking, why this term scalar? And we remember that we were calling, when we had our brackets, okay, and we're just doing the algebra, we said the number outside of the bracket is called a scalar, all right? And therefore, with multiplication in matrix, because the matrix is made up of maybe sometime this 2 by 1, okay, we can get that it is 2 open bracket, and it can be 3, 4, 5, 6, or we can even just have a column matrix where you can have 5 and you can have 3, 4, 7, okay? Or even a row matrix where you can have 3, 8, 9. And we have to do the multiplication. This is called scalar multiplication because there is a number outside. It takes its name from the number outside. The number outside is called a scalar, all right? And it can be a letter too, all right? But we call it a scalar. So here, this then is following what we used to talk about, our room with our bathtub and our Clorox, okay? If we throw some in here, it's going to go in all the clothes. It happens here again too. The number outside must be multiplied by each element inside. So again, we are following our distributive law, okay? The number outside is multiplied by everything that's inside. So what are we going to get in our first case? First case here, it would be 2 times 3. It would be 2 times 4. It would be 2 times 5. And it would be 2 times 6. So everything inside the bracket is multiplied by the term, by the scalar outside. And so the answer here is just 2 3s would give me 6, 2 4s would give you 8, 2 5s would give you 10, and 2 6s would give you 12. And that's the answer. Yes, there's nothing more to it, okay? There's nothing more to it. Over here, you would be doing the same thing. So it would be 5 times, and here it would be 3. It would be 5 times. Here it would be 4, and it would be 5 times, and here it would be 7. And so your answer would be 15, 20, 35. And that is the answer. Okay, if we had to come over here again, it would be 7 times 3. It would be 7 times 8, and it would be 7 times 9. And here your answer is just 21, 56, and 7 9s would give you 63. Okay, and that is the answer. All right. Now, because our matrix multiplication is a bit more involved, we are going to leave you today with your having done, wow, how many rules? The rule for addition, the rule for subtraction, beginning the first rule for multiplication, and it is something that we already know. And sometimes you're just going to get given matrix M is equal to 4, 5, 7, 8, and they can ask you to find 2M. And you know right away it just means 2 times 4, the 5, your 7, and your 8. So that takes care of a scalar multiplication. Next week, I'm going to start just with a review first, take you into the matrix multiplication, see how quickly we get on with it, because I know you're now sparking and saying, well, Miss Weston, them some here joke, them so many people talk about mathematics. This is what you're saying that you can do. Yes, there's nothing big about it, but we have just got to take time to make certain the principle is taught properly, that people understand where and how they're using the stuff. And once you learn it, you don't have anything else again to learn from your first year, second year, your third year, fourth generation. This is it. All right? So take the time, sit with your children, sit with the students, because as I tell you all the time, sometimes academic work can be so boring. But just a little companion, just a little competition, just somebody say, come on, if mommy can do it, you can do it. If daddy can do it, you can do it. Just keep testing them, all right? And you will see how they get on. And our primary school children, please don't forget to let them learn those tables. Yes, very, very important. And you will see how powerful they are. And teachers, I beg of you, beg of you, do not send the children home with 40,000 different objectives because they're on the same page in the workbook. I can't see that you're going to give a little child something that they're rounding off, then they have to go and do Roman numbers. If the author wrote it as that, that's bad. You understand? So you don't just say, take out your books, turn to page 56, and you're going to complete that for your homework, and give them several different advantages. And for my secondary teachers, when we're marking mathematics, it's not just numbers, okay? Right now, this particular topic is just showing you numbers. But when people get topics like you have consumer arithmetic, and they're saying 20% is taken off from so-and-so, you go down to Courts and you're buying a fridge, and if you pay cash, you do this, or if you're doing you're actually taking this stuff on credit, there is this scheme, 20%, and you pay 10 monthly payment and so forth. For that type of question, the students must be taught to write logic and reasoning, how they are arriving at answers. I no longer want to just take up a child's book and just glance in, and when I think that that book is just where they're doing the rough work, they're telling me, no, that's the book they give up to their teachers, and I have to ask, what was the question, or what was the sum? Anybody's supposed to be able to take up a book. He or she must look, see the statement the students are doing in that book, and will be able to say, I know what topic this is. But not to ask them, what was this? And when they look back about 3 or 4 months later, they don't even remember what they were doing. Reasoning and logical development is important. Please pay attention to those things. In the 60s, when I went to school with Teacher Hyson and Teacher Pepsi teaching these things, and Teacher Muriel and Miss Scotland, you want to see how neat your book looked in junior 5 in the public school, all right? You had to write reasoning, rule up your stuff, and it's now still being done. Teachers, do not give up on that, because the profile, computation, comprehension, reasoning, and logical development. And although you may get high marks in computational comprehension, if you go down in reasoning and logical development, you're going to get a failing grade. Or you're not going to get the high profile of a 2, you're going to go down 2 or 3. And you're going to wonder and say, but how your profile is the same, A, B, C, and I just have my C's in a different position. Reasoning is important, and we have to start developing that now. So do not let me open another child's book and just see numbers just all over the place, and they're doing that, and then they say, I don't know, where is the sum? When you look at the sum, a crisp thing, you know. A TV set is sold for $300. If it is bought for cash, this is what you pay. If you're using our second scheme, there's a 20% discount, and then there is so-and-so. And then they're asking them certain questions. We don't just want to see the answer, we want to see a build up to the answer. Reasoning and logic must be there. Again, that is why we're saying English is so powerful in the mathematics classroom. And so it's not just numbers in the book we want to see. We want to see logically set out sums, well ruled up, okay? It's not all the schools that this take place. But principals, please check and see what is happening in your school. Please check and see what is happening, okay? So, until next week, this is Karen Weston and Silent Jetta behind the camera, wishing you a pleasant week, and do continue to make education a priority in your life, and by extension, your children's. See you next time.
Join us next time for another in the series, Mastering Mathematics, a production of the Education Broadcasting Unit in the Ministry of Education and ABS TV.